Okay, this is the final review, and I'm starting with question 62. So I'm starting at the end, and I'm going to post them backwards. So this problem, a deep sea diving bell is being lowered at a constant rate. And I have constant rate highlighted in red because that's an important detail. After 11 minutes, the bell is at a depth of 300 feet. After 30 minutes, the bell is at a depth of 1900 feet. What is the average rate of lowering per minute? So to start to set up this problem, we have to put the clues together. And one of them is it's telling us there's a constant rate. When there is a constant rate, and if you know your formula, y equal mx plus b, the slope is a rate. Every time that we're looking at problems where we had, let's say you're going to rent a car and they had a flat fee, it costs up front $25 and then you're paying 23 cents a mile or something. We learned that the flat fee belongs where the B is, and that 25 cents a mile is the rate. And you're going to multiply, and X would be each mile that you may have put on your car when you rented it. So, and oftentimes these were equal to cost. So Y was the cost, or the output was the cost. So, a slope, when there's a constant rate, we can assume that it'll be a linear equation with a constant slope of m. So we can use the equation for slope, or it's also the equation for rate of change. And that equation, of course, is the y2 minus the y1 over x2 minus x1. And I've explained in other videos that why these little subscripts are down here. And that just indicates that if you have a point, x, y, and you have another point, x, y, you have to distinguish between the 2 points. You call this one point 1 and this one point 2. So they put these little subscripts on the x and the y so you can follow them. This is the x from point 2. This is the x from point 1. So that's the x from point 1. This is the x from point 2. And that's just a little quick explanation of why those have those subscripts. Now, we just have to sort out then what is x and y. What are these coordinate points in this problem? And what we have is 11 minutes. After 11 minutes, the bell is at a depth of 300 feet. So to continue with the graph idea, if we graph these points as time as on the x-axis and y as the depth, oftentimes time is often the x-axis. That's how we can interpret this information into x and y coordinates. So the 11 minutes, which would be roughly here, at 300 feet, which would be roughly here, you would have a point. So what we could say is whenever you're building a point, you've got an x and a y. That's x and y. The time becomes x, and the depth, 300 feet, becomes the y. And that's how it would fit into our linear equation as the x and the y, or into our slope equation. So, but in order to complete this slope equation, we need 2 points, and we are given 2 points. We can also plot this one, 30 minutes at a depth of 1900 feet. So 30 minutes, at a depth of 1900, which brings us to pretty much 2000, right there. We've got 2 points, and with 2 points, you can draw a line. We don't know what the y-intercept is, so we're just going to draw it that. Now we know what our points are. This is looking pretty sloppy here, so I'm going to type those points. What we plotted was 11 minutes and the depth of 300 feet. And then we plotted another point of 30 minutes at 1900 feet. So now we can plug these coordinates into our equation. This being an x and a y, this being an x and a y. If this is point 1 and this is point 2, then we can put down, we can fill in y2, which is 1900. So we'll fill that in, 1900 minus the y of the point 1, which is 300, over the x of point 2, 30, minus the 11 minutes of point 1. And let's put that here. We've got feet and minute. And then we subtract, so it's 1600 over 19. And you reduce, which comes out to roughly 82. Let's look at that. That's a calculator. 1900 divided by, clear. 1600 divided by 19. 18.2. So, once you divide that, you get 80, whoa, 84.2. I don't know what I was saying. Okay. 84.2, and we have feet per minute because that's what we divided. And that's correct, and we can check that right here. What is the average rate in lowering per minute? So we know that we lowered in feet per minute. So that's how you do this problem. You think of it as a rate of change problem.